Hello again, folks, and welcome to the 7th section of the course. In the previous section, we learned how to write a streaming JSON API to interact with our data. In this section, we will learn all there is to know about concurrency in Go. We'll start with the basics of concurrency, then build a simple chat server, then build a more capable chat server, and finally create a system for sending notifications in real time. Moving on to the first section of the video, let's talk about concurrency in Go. In Go, there are two core concepts in terms of concurrency: Goroutines and channels. Go will probably feel different than the concurrency you have experienced in other languages, and it is based on Tony Hoare's paper called Communicating Sequential Processes. There is an incredible visual guide in Go's concurrency at divan.github.io/post/Go concurrency visualize, so please check it out if you have a moment. In Go, each concurrently executing activity is called a goroutine. Goroutines are almost the same as operating system threads in other languages and can be thought of in the same way. There are two major differences, however. The first is that each operating system thread has allocated a fixed-size block of memory for its stack, but the goroutines is not. Its stack can grow and shrink as needed. The second difference is that an operating system thread is scheduled with the kernel, whereas goroutines are scheduled via the Go runtime scheduler. Channels are a communication mechanism that allows one goroutine to communicate with other. Channels have just two operations: send and receive. Let's take a close look at this code. You can see on line 20 we make a channel. A channel needs a type just like everything else in Go. On line 22 you can see we use the Go keyword to start a new goroutine. We're actually starting a new goroutine for each GET request here, and we're sending the response over our channel. Also, the Go keyword can only be used on functions. To make this easier, we can use this syntax to call an anonymous function where we pass the value of our desired site's URL as string. On line 31 here, we receive over the channel and print out the value. It is really as easy as that. Let's try this out. Try running both of these functions and see how long they take to run. If you want to see a more noticeable difference, try adding more URLs to the array at the top of the file. I'm going to run this with 8 URLs. Look at the results for sequential running. It took around 5 seconds, which really isn't too bad. I wonder if we'll see a significant performance difference when we run them all concurrently. Whoa! Just over a second. That's a significant improvement. Of course, these results will vary depending on connection speed, but you get the idea. It's way faster to do this task concurrently and really wasn't that much harder to code. We have really only skimmed the surface as far as Go's concurrency model goes, but if you feel okay with the code above, you already got a great grasp of the topic. In the next video, we'll build a simple chat server that echoes any message sent to it and learn some more about concurrency. Excellent!